Hello, everyone. Thanks for joining us today for our May 2023 issue of our AMS webinar series. My name is Don. I'm MecSoft's Tech Support Manager. I will be doing the presentation today. I'm also joined by Pankaj, who is a MecSoft Senior Application Engineer. Normally, we are joined by Joe Anand, our Product Manager, but Joe is on some much-needed vacation. So I'll be running the show with Pankaj as backup. Now, we did have some technical difficulties at first getting started, and we apologize for that. Hopefully, we can get the rest of the presentation done without any issues. And we will go over it in order to finish the webinar, so no concerns about that. So today's webinar is on learning to machine 2.5 axis prismatic parts. So what's a prismatic part? Basically, it's a 2.5 axis part where all the side walls are vertical. Typically, we're talking about pockets, facing operations, profiling, engraving, things of that nature you can do on prismatic parts. And what we're going to do today is we got a short presentation, and we're going to spend pretty much all of our time in the training portion doing the demonstration. So today's agenda, as I mentioned, we're going to be discussing 2.5 axis prismatic parts. We're going to be talking about the geometry definition, setup and stock alignment in 2 axis. We're going to be doing demonstrating 2.5 axis facing, pocketing, profiling, engraving, slotting, and chamfering all in one video. We're going to be programming a part from start to finish. Also, we're going to be doing some drilling and cut material simulation and post-processing. As usual, you can enter any questions that you have into the GoToWebinar dialog. Where you logged in, you got the GoToWebinar dialog up. You should see a tab that says chatting. Looks like a bubble. In there you can enter any questions, and we'll see them here on the back end, and we'll get to them. If we have to, we'll stop the webinar and answer your questions. There will also be a question and answer period at the end of the video if we have any other questions. And also, we are recording this webinar, and we'll make it available to you in a day or so. Okay. The part that we're going to program today is on the screen. It's a 2.5 axis prismatic part. It's a circular part, about 7 to 8 inches in diameter, about 1 inch thick. It's got a number of 2.5 axis features here: facing, pocketing, profiling, chamfering over here, slotting, and engraving over here of a part number. So we're going to be doing all of those, demonstrating all of those operation types in this video. Okay, let's keep going. So now we're going to that's all the presentation. We'll go straight into the demonstration. Let's bring up RhinoCAM. At the world origin in Rhino, and that represents setup 1. So we're only going to be doing one setup. We're not doing any flip machining or anything else. We're just doing basic 3-axis from one direction, which is the top of the part. So we're going to go ahead and we're going to go over some things that you need to do for any CAM project when you get started. Open up your part file. You need to take a look at what you have to program, obviously. So some of the things you need to check. The first thing you need to check is your units. So you need to make sure that you understand whether the units are inches or millimeters. They have to be inches or millimeters. If it's any other unit, then the CAM plugin will not load. So it has to be inches or millimeters. This part is in inches. Also, you should understand the type of geometry that you have. In our case, We have a poly surface model, what you call a solid model, okay? And also some other things you need to look at is you need to understand the size of your part, and you can do that pretty quickly by going to the stock box icon here on the machining job. Just double click it and pick copy model bounding box. If you have any wireframe geometry, check this box to ignore it and pick the copy model bounding box, and you'll see that we have a stock that is 7 inches by 6 3/4 by a little more than 1 inch high. Okay, so what we're going to do is we're just going to add a little bit of material here. 7.125, we'll go 6.875, and then we'll go 1.125 for the height. We'll pick OK, and then we'll also, we got the stock set. Let's go ahead and align it. So we're going to align it to the bottom of the part, so we have extra stock on the top, and we're going to align it at the center. Pick OK. We'll turn the stock on. Now, we're working from the program tab from left to right. So for the machines, for 2-axis and 3-axis, it's both set to 3-axis. So you want that set to 3-axis, manual definition, and pick OK. For the post, obviously, if you're whatever controller your CNC machine has, you're going to be selecting a post for it. For this demonstration, we're just going to use the Haas post, just the standard Haas post. Pick OK. So we got machine 3-axis, the post is set to Haas. We did our stock and we aligned our stock. We don't need to do anything under setup because we have a setup 1, and by default that's located at the world origin of the CAD system, and we have our part oriented there. Okay, so another thing that you want to think about before you actually get started is how you're going to mount this part on your router bed or your CNC machine bed. For this part, we have all the features except for these two holes coming from the bottom. All of these are coming, all the features are being cut from the top. So what we'll do is we'll, for this part, we'll just clamp it on both sides with some low profile clamps, and then we'll perimeter around it just to a certain depth to avoid your clamps. Okay, so now let's go ahead and turn the stock off for a moment. Now, the next step you need to do is you need to look at your geometry and make a determination if you need to add any additional geometry. You may need to draw some lines, circles. In 2-axis machining, typically you're going to be adding, two-dimensional geometry. If it's a 3-axis part, you may need to add some additional surfaces to help guide the tool. In this case, I'm going to add some wireframe geometry that will help facilitate the programming of this part. So I'm going to draw some lines. You see I got a step down right here to machine. So what I'm going to do is I'm going to draw some lines, and I'm going to change my object snap to N, and I'm just going to draw some lines from here over to here. Okay, and I'm going to do that on this side and also on this side. And again, this will just help us program the part. Okay, so we got those lines. Let's go ahead. We'll just leave them there for now, and we'll take care of them when we get to it. Additional geometry. You notice that we have some pockets that are kind of interrupted here. We probably want to put a circle at the base of this pocket. Let's go ahead and draw a circle. And we'll set the center object snap, and we'll just put it right here. So we got a circle there, and also we have some pockets that we probably should draw a circle in here as well. Let's go ahead and do that. Okay, got that one. Let's go over here and do that same thing over here. Okay, good. So that'll help us when we go to program these areas that are interrupted. Just one second. Now let's see if we need any more geometry. Okay, that looks pretty good. We may want to have a perimeter diameter. We can throw that in. I'm not sure if we'll use it or not, but let's go ahead and put a circle in. We're going to do it from the center out. Okay, so we got that circle in there. You can see that. Okay. Now, how do we want to approach programming this part? Well, as you can see, all of the features that we're going to machine are cylindrical. Okay, so we got a big pocket in the middle here we need to hog out. So let's go ahead and drill a large hole in the middle of this part right at the program 0. That will help get some material out of there and will help when we high-speed pocket this out. So let's go ahead and take a look at what tools we have. Define. Okay. Saying looks what drills we got. Let's take a look at the tool dialog and look at drills. Okay, so we got a 3/4 inch drill. Let's go ahead and create a 1.5 inch drill. So I'm going to go 1-1/2. Okay, and make the tool diameter 1.5. And the shank diameter 1.5. Okay. And let's see, 1.5. Tool length is 4. The flute length is 1.5. That should be okay. Okay, that looks like it should be okay. And we added a tool holder. And feeds and speeds, we're not going to be setting any feeds and speeds for the demonstration, obviously, because you're going to use the feeds and speeds that are required for your machine and the materials that you cut. So we'll go ahead and we can put just some feeds and speeds in here just to for this part itself. Okay, so let's go ahead and pick OK. It just populated some feeds and speeds. We're going to go save this tool. So we have a 1.5 inch drill here on the left. We're going to pick exit. So what we're going to do some drilling first. We're going to drill a 1.5 inch hole in the center, and then we're going to also drill some spot drilling in these pocket areas to just help facilitate the rest of the drilling or pocketing of those holes. So let's go ahead and we'll do the hole menu and pick drill. And one thing to note here, for drilling, all you need to drill and all that it's going to be calculating in order to drill is the point at which the drilling occurs. So if you're drilling on a diameter, it's going to calculate the center point of that diameter to locate the drill. So the reason I'm telling you that is that you only need one entity per hole, and that entity will either be a point or it'll be an arc. If it's an arc or a circle, then the program will calculate the center point and position the drill at that point. Obviously, if it's a point, it'll use that point. So what I'm getting at is you don't need to select circles to drill. But in our case, we do have circles, but we have some interrupted circles. Okay, so what we're going to do is we're going to pick the select drill point circles button, and for the spot drilling, we're going to do some spot drilling on these holes. So I'm just going to select these holes here, and you'll see that for this one I'm only selecting one edge. Close my door. As I mentioned, one entity per hole. So we're just going to pick this one partial edge and we're going to work our way around. And we also want to do a spot drill in this larger pocket counterbore of this slot. So we'll just pick this out, one of this entities on the outer diameter. We'll just work our way around, work our way around. As I mentioned, these holes are being programmed from the bottom side, so we're not going to mess with those. We're going to do that. We're going to do that. And we'll do that. Now, if you do happen to select multiple entities for a single hole, it's going to drill it that many times. So don't select more than one entity per drill point. Okay. So it looks like we got them all done. So, okay, so let's go ahead and select our drill. See what we got here for a spot drill. We got a center drill, 1/4 inch. Let's use that. Feeds and speeds, cut parameters. We'll do a deep drill. We're going to go down just 1/8 of an inch. And the locational cut geometry we'll say is at top. And we're going to step increment 6 or 05. Okay. In sorting, we got a bunch of holes, so we're going to do a directional minimum distance sort. Okay. So there's our our center drill for those drill points or pocket points. Also, we want, as I mentioned, we're going to do a drill, a large 1.5 inch diameter drill in the center. Let's go ahead and do that. Pick drill. For this case, we're just going to select just one of these edges. And also, I want to mention here, when you drill, you have to select a circular edge, an arc, a circle, okay? It has to be either an arc or a circle or a point. No curves, no spline curves, nothing that is not recognized as an arc, a point, or a circle. Okay, so we selected a circular arc. It'll automatically determine the center point for us. So for the tool, we're going to use the, let's see, 1 1/2 inch drill. For the cut parameters, we're going to do a deep drill. And let's go in a step increment of, I guess 125 is okay. And the locational cut geometry is at the top of the part. And for the depth, let's just go ahead and calculate that. Pick a point on the top and a point on the bottom. So it's 0.0625. So let's go ahead, and everything else looks good. Let's just generate that. Okay, so there's our hole. Let's go ahead and simulate these holes. Oh, okay, let's see what's going on there. Looks like our flute length is not long enough. So let's go into here. Let's look at that. Look at that drill. Okay, a flute length. Flute length is 1.5. That should be okay. Tool diameter 1.5. Let's go that up to 2. Do that to 2. Okay, tip angle, shank diameter, everything else looks okay. Let's go ahead and save it as the tool. Pick OK or exit. Let's generate that again. And we'll go to view, for viewport layout. Okay, that's what it is. Let's go ahead and take a look at the depth. Okay, 1.062, and we're adding the tooltip. Let's see if we can go ahead and simulate that. Okay. Let's go ahead and play that again. Let's turn the stock on. So we've got that through hole drilled all the way through. Then let's go also, we'll simulate, let's go ahead and move this one up and we'll simulate the spot drills. Okay, looks like we're deep, cutting a little bit deep there. Okay, let's go ahead and shorten the depth, the drill depth. Let's go 0.06 and I'll simulate that. Okay, that's better. So these are the spot drill locations for those pockets. Okay, so we got those done. Let's turn the stock off for a moment. Now, what do we want to program next? Let's go ahead and rough the inside of this out. There's a number of different ways you could do it. I'm just going to do it with a high-speed pocketing operation. And let's go ahead and we'll select our last operation. We're going to go to 2-axis pocketing. And we're going to select, we'll just select this bottom edge since it's circular at the bottom. So there's our perimeter that we're going to pocket. And for the tool, we can go ahead and use the 1 1/2 inch. I don't see it there. Oh, okay, that's because that was a 1 1/2 inch drill. Okay, let's go ahead and use our 1 1/2 inch flat end mill for that. Well, let's go ahead, let's just create a tool. Okay, so let's go over here and we'll do an end mill. And let's do, instead of 1/2 inch, let's do a 1 inch. Okay, 1 inch. And we'll change this to tool diameter of 1, shank diameter of 1, the same flute length, same shoulder length, same tool length. Everything else is going to be the same. And we're going to pick Save as New Tool, Exit. So now we got the 1 inch. And we're going to go to the cut parameters, the tolerance, change this. This is actually going to be a roughing and finishing at the same time. So we'll have a tolerance of 1,000, a stock of 0. We're going to do a high-speed cut pattern. And in the high-speed pattern, it's going to start at the center of the geometry, which is the center of our hole, and then it's going to spiral outward. So let's go ahead and the step over, leave that set at 25%. We'll do a cleanup pass. Okay, for the cut levels, the location of the cut geometry is at bottom. And for the total cut depth, we're going to just go ahead and pick 2 points. Since it's 1 1/16. Okay. For the depth per level, we'll just go at 1/8 of an inch. And for the entry, it's going to be a path. So what's going to happen is it's going to enter in a helical motion, and when it starts cutting, it's going to start expanding outward till it gets to the perimeter. Okay, so let's go ahead and fit arcs. Okay, let's go ahead and generate that. Okay, we don't have any arcs, so let's go ahead and see why we're not having arcs. Let's go into the CAM preferences. Go to output control. You want these boxes unchecked if you're going to output arcs and helixes. So pick OK, and then we'll regenerate. Okay, so now we have dark blue motions, which are circular arc motions. So let's take a closer look at this. So you'll see that it's a circular entry motion or a helical entry motion, and then when it engages, it's just one continuous high-speed radial motion. Okay, so let's go ahead and simulate that. Okay. Okay, we got that hogged out or finished out. Let's go to the Program tab. Now, next on the list was a number of different ways we could do it. I'm going to go ahead and face it and cut these pockets in here. We'll go ahead and do that now. And let's do a 2 1/2 axis facing operation. Now, for facing, we only need to face between these two diameters. We don't need to face in here. So we're going to go ahead and select. We'll just go to the bottom and we'll select the perimeter, inner perimeter, and the outer perimeter. Okay. So we got 4 entities selected. So it's going to face between the 2 entities. For the tool, we can go ahead and use our 1-inch tool. For roughing, we'll go ahead and set the tolerance to a finishing tolerance. Tolerance in 2 1/2 axis is only on the side walls, not on the depth. We're going to leave a stock of 0. I'm going to change that in a moment and I'll show you why, but let's do it at 0. And mixed cut direction, a step over 25%. We're only going to have 1 cut level. Okay, and we're going to, since the geometry we selected is not on our cut, so we're going to use the pick top, and we're going to say the top is right here, and then we're going to cut 0 depth, which means we're going to have 1 cut level. It's going to be at this point level, at this face right here, 1 cut level. Okay, for the entry and the exit, we'll go lines and arcs. And advanced cut parameters, we'll go ahead and do some arc fitting, and let's generate that. Okay, so we got a facing operation going through around these 2 perimeters. Let's simulate this. Now, you'll notice that the tool didn't go past the inner perimeter and it left some slivers of material here. The reason I did that is I wanted to make sure you understood that in facing, if you have an inner and an outer perimeter, okay, 2 nested perimeters, the center tip of the tool will stop at the outer perimeter, the center. The diameter of the tool will stop at the inner perimeter. Because you might, this inner perimeter might be a boss. You might have a boss sticking up there. In 2 1/2 axis, the program doesn't know the features that you have. It only knows that you selected 2 diameters or 2 perimeter curves. So in order to clean that inner edge up, we're going to go in and adjust the stock allowance. So we're going to do a negative stock. What that's going to do is it's going to push the diameter of the tool inward in a negative cut direction. In other words, it's going to go past it by 125. Okay, so let's generate that again, and then let's simulate that again. Okay, so you see it went past the perimeter by 1/8 of an inch and cleaned that edge up nice and clean. Okay, so we got the facing. Now we've got these 2 areas, or 4 areas actually, which are their faces, but they're at a different level than this top face, and it's also interrupted here. Okay, so that's the reason why I drew these lines. Okay, the way I'm going to program it is I'm going to use profiling. Okay, and I'm going to show you why and how that's done. So the first thing I need to do though is I want to trim up these lines. So let's do some trimming. Okay, and we're going to trim these, and then we're going to select these, and we'll trim that. Okay, let's go to the top view. Okay, so now I'm going to select these 4 lines and I'm going to merge them. Okay, so now we got 4 curves at, meeting at right angles along those edges. Okay, so if you got any questions, feel free to put them in the questions panel and we'll get to them. So now what we're going to do is we're going to do a profiling operation. And we're going to go to Axis, Profiling. We're going to select these 4 curves, merged curves. Okay. And then for the tool, we'll go ahead and use the 1/2 inch end mill. For the cut parameters, tolerance of 1 thou, 0 stock, we're going to cut right up to the edge, a mixed cut direction, and we'll do the determine using 3D model. That'll figure out which side to put the tool on for us. Now, I want to cut this whole area on this side of the curve and on this side of the curve to make sure I get this area covered. So what I'm going to do is I'm going to put a width here. So let's go ahead and do some measuring here. Let's just check and see what the distance is from here to here. So that's 2.3. So let's make that 2 inches to start with, see how that goes. And then we'll make this at 1/4 inch offsets. Okay, the cut levels again, the locational cut geometry is at the bottom, so we're cutting down to this point, and the total cut depth is going to be 0. Okay, so we're going to cut 1 level at this bottom location. Entry and exit, we'll go ahead and do lines and arcs. Advanced cut parameters, we'll do arc fitting, even though there's no arcs. We probably won't get any arcs. Cornering, sorting, we'll just leave that. Okay, so what did we get here? We got it covered. We got a little bit extra covered. We don't really need it to go out this far. So let's go ahead and make some adjustments. Let's set this to 1 and see how that works. All right, that looks better. That looks like it just might do it. Let's go ahead and simulate that and see what that does. Let's turn that off. Okay, it looks like the entry needs to be moved out just a little bit. Okay, so let's make some adjustments here. Let's go into here, go to the entry and exit tab, and let us do approach motion distance length. I'm going to set that to 0.75, and then the exit distance length, departure length, 0.75. Let's see if that helps. Let's take a look at it. Okay, great. So what you see is we added some extensions here on the entry and the exit, so that brought it out, hopefully past the perimeter, as we're using square stock. So let's see what that does. Okay, so it looks like it's not quite enough either. Let's go ahead and pause that. Let's stop it. So what is another way to add some extension? We can increase the diameter of this radius right here for the entry and the exit radius. Let's go ahead and do that. And we'll change the radius to, instead of that, we'll change it to 0.75 and 0.75 with the entry and the exit. Okay, that probably will do it. Let's see how that looks. Yeah, that's good. Very good. Okay. Okay, so as I mentioned, let's turn this stock on. There's more than one way to program just about anything. I simply choose to do it this way. You could have put a square rectangle here and just pocketed it. You know, that would have worked. You could have done facing on it, right? You probably would have had to extend this line out a little bit further because if you're facing open pocket areas, it's just going to connect from the endpoints to cross over. So you need to make sure that you get out past this point on the part. But we chose to do it with profiling, which worked just fine, I think. Okay, so what do we need to do next? Okay, so we got our center hole, we got our facing, we got our profiling for these step downs, we've got our pre-drill points. Let's go ahead and tackle the radial slots. So if you look at that from a top view, you'll see that we have two slots, okay? They are on the same diameter, okay? And they are on opposite sides. You know, this counterbore area is at the top, this counterbore area is at the bottom. So what we're going to do is we're going to add some additional curves to help machine these slots. Now, as I mentioned, there's different ways to do this as well. What we're going to do is we're going to draw the center line of the slot from the center of this curve to the center of this curve on that angle. Okay. Now you could just pick the perimeters of this slot and just pocket it out. You could do it that way as well, but we're going to show you how to do it because the tool we're going to use is the same diameter as the slot. Okay. If you want a slot with a tool and the slot's the same diameter as the tool, you need to do this method. If you try to do it with pocketing, you'll probably get an error because of tolerances. It won't let you fit a tool that is the exact same size of the pocket that you're trying to cut. So in slotting, that restriction is overcome because we're because this operation is specifically designed for slotting. So let's go ahead and we'll go to an isometric view, and let's go ahead, let's do this from the bottom, be a lot easier. So the first thing I want to do is I want to draw a circle at the center and at the center. So we have a circle through both slots. Now we want to trim up that circle so that we only have the center line of the slot itself. So let's draw some lines. We'll go from this center to that center, this center to that center, this center to that center, this center to there. Okay, so now we've got those and we're going to trim those up. So we're just going to go select all of these and then we're going to trim. Okay, we don't need those anymore. So now you'll see that all we have is the center line spine, we'll call it a spine curve of this slot. So now we can go ahead and do the slotting operation, 2-axis slotting, and we'll get rid of those. We don't want those. We're going to select these two spine curves. Okay, so we got two curves selected. Okay, and let's go ahead and make sure we understand the diameter of those slots. Let's go down here and do it from in here. Okay, so that's 375, so 3/8 of an inch wide. Okay, so we're going to go ahead and use, I think we have a 3/8 inch flat end mill. And for the cut parameters, a tolerance of 1 thou, 0 stock. Now remember, the tool is the same width of the slot, so if you attempt to give it any stock, then it's not going to it won't calculate it because you're going exactly that width. So let's go ahead. Well, let me back up and rephrase that. It probably will calculate it, but it will do a step over. We'll just see. We're not going to do it that way, but I'm just talking out loud here. So we're going to do for the slot parameters, 1 thou tolerance, the slot direction, natural and reversed. That's just the direction of the curve. And we'll go ahead and turn that off. We don't have, this is not really going to apply since we just have one path that we're going back and forth for the slot. So for the cut levels, the location of cut geometry is at the bottom. And for the total cut depth, is 1 1/16 of an inch, and we'll go down a quarter, 1.25, eighth of an inch. Okay. For the pocketing entry, we'll just do a path, and we don't need any sorting, and we can apply the entry at each cut level. Let's do that. Okay. So that is not what we wanted, so let's see what's going on there. Let's go to the slot parameters. Okay, that's the problem. Slot width that was set to 1/2 of an inch. We want it set to 375, 3/8 of an inch. Let's pick generate. Okay, that's a lot better. So let's look at that. So we've got 1/8 inch cut levels. We got ramping going on at each cut level. Let's go ahead and simulate that. Okay, there we go. We got those two slots done. Okay, let's go over here and decide what we want to do next. Okay, so we got a bunch of pockets. We can go ahead and do these pockets. And what the neat thing that I'm going to show you is that you can do all of your pockets at the same operation, even though they're different depths. So let's go ahead and show you that. Sorry about that. Okay, so let's go up to 2 axes, pocketing. So we'll move those, and we're going to pocket at the base. Now, if you're going to pocket multiple pockets and they're at different depths, you need to select the bottom of each pocket, not at the top, okay? Because if you do all at the top, it'll just be one fixed depth, okay? So we're going to do them at the bottoms. That's why I selected drew these circles in here, okay? Let's go ahead and select some curves. We're selecting all of the bottoms of the pockets, and that's why I drew this curve. So I'm going to make the pocket as one circular pocket. Let's work our way around. Work our way around. Okay. Do this one. This one. Okay. Looks like we got it. Let's look at what we got here. So we got the bigger pocket, and we got the smaller pocket. So we got let's just do it again, big pocket, smaller pocket, and then we're going to work our way around. Okay. So those are all the pockets that we're going to program in this one operation. For the tool, we'll go ahead and use the 1/4 inch flat end mill. And for the cut parameters, we have a tolerance of 1 thou, 0 stock. We're going to do an offset cut pattern, a mixed cut direction, a 25% step over, and we'll go ahead and do a cleanup pass, And for the cut levels, now we have multiple depths. So for your cut level, we're going to program the deepest pocket, okay? So the deepest pocket is one of these here, not this one. So we're going to go ahead and say at bottom for the geometry, and for the cut depth, we're going to calculate the depth of this pocket. So let's do here to here. So that's 365, and let's divide that up by 1/8 inch cut levels. For the pocketing enter and exit, we use a path, which will end up being a helical entry. And we'll set an entry at each cut level. And we'll also fit arcs. Let's generate that. Okay, let's see what that come out to. Okay, let's go to the front view. Okay, so you see it cut down to each depth. They're different depths, okay? So it calculated a cut level for each of these pockets that are different depths, okay? Let's go to the top view again. That's what it looks like on the top view. And then let's go to an isometric view. Okay, so let's go ahead and simulate that. Let's turn the toolpath off. And let's go ahead and play. So it's doing the helical entry at each cut level and doing the slot counterbore. Now, since we started late, we had technical difficulties, we're going to go ahead and go over as long as it takes to get this part programmed. I'm sure you want to see how it turns out. So here is the bigger pocket there. Okay, there we go. We got all those pockets done. One operation, different pocket diameters, different depths. So that'll save you some time in the future, knowing that you don't have to have an operation for each pocket that's a different depth. Okay, as long as your parameters are the same as what you want and the cut levels are the same, then you can use one operation. Okay, so what do we have next? Okay, so we got all of our counter bores done. We can go ahead and do these through holes. And in fact, we can just go ahead and use the same operation, the same pocketing operation. We're going to clone it. Okay, and then we're going to edit it. We'll get rid of those. This time we're going to select the perimeters at the bottom. Okay, since all of these holes go all the way through. So let's go ahead and pick our select curves button. We're going to start picking our pocket, our holes here. So we're not doing these ones. These are being cut from the bottom. So we'll do that one. That one's pretty small, so we'll see if we can get a tool in there. We'll do that one, that one, that one, that one, that one, and that one. Okay. Okay, so we got all of our holes selected. For the tool, I think we can go ahead and use a 1/4 inch. Let's go ahead and analyze what the diameter of this hole is. Analyze diameter, 257. That should work. That should work. We'll see. And for cut parameters, everything's going to be the same. Cut levels. Okay, we want to change the cut level. So we're at the bottom for the geometry, and then for our cut depth, we want to go and use the highest pocket now, okay, to start calculating. So that would be this one here, okay, from there to there. So that's 0.7925. And again, we've got a rough depth per cut at 1/8 of an inch. We're going to use a path entry, which is going to be a helical ramp. Okay, it's going to be at each cut level. We're going to fit arcs. And we're going to do sorting here. Let's do a minimum distance sort. Okay, let's see what that looks like. Okay, so we got those pockets. Let's see this smaller hole here. Yeah, got a lot of spiral motions there. I guess that's okay. Okay, let's go ahead and simulate that. So it's doing a spiral helical entry at each cut level. So it's doing cut level, retracting, radial entry, cut level, retracting. We're doing that at each cut level. If you don't like that, obviously, you can just uncheck that box to do the entry next to each cut level, and it'll just do one spiral entry on the first cut level and then just drop. Okay, so let's get this done here. All right, there we go. Let's turn the toolpath off. So we got that hole done. We got all of the through holes all programmed. We're getting close. It looks pretty good. Okay, now what do we have left? Well, we got the chamfering and the engraving. Let's go ahead and do the chamfering. Now for chamfering, you want, if your chamfer is modeled on the part, then you're going to be using the bottom edge of the chamfer, not the top. So the bottom edge is what we're going to be selecting. If there's no chamfer there, obviously, you're going to be using the top edge because that's the only edge that's available. So let's go ahead and do 2 axes. We're going to do chamfering, and we're going to select these bottom edges. We're just going to work our way around. Nope, not that. If you select something that you don't want, just hold the control key down while you pick, and it'll unpick it. So we got that edge, that edge. I'll go over here, that one, that one, that one, and that one. Okay, so we've got those edges selected. We're going to use the only V-bit that we have. For this operation, you can chamfer with a V-bit or a chamfer mill, which is just it's a flat end mill with a flat on the bottom with tapered sides. We're going to go ahead and use the V-bit because it's a 45-degree chamfer. Okay, so we've got the chamfering operation done. Let's go ahead and take a look at that. Zoom in a little bit. We're chamfering on the right side. You see that the tip of the tool is down below. Let's just double check something here. I want to see the tool tip clearance. So we have a tool tip clearance of 5 thousandths. Okay, so what that means is the tip of the V mill is extending past this edge by 5 thousandths. Okay, so let's look at this from a front elevation, or actually from, we'll do a right side elevation. Okay, so if you look at the tool path, you'll see that here is the chamfer and is extending 5 thousandths below the edge of the chamfer to get a nice clean edge right here. Okay, so let's go ahead and we'll go back up to the top view, isometric view. Okay, let's do those chamfers. Okay, let's simulate this, slow this way down. Okay, okay. Okay, and let's play that. Okay, so we need to simulate the rest of those real quick. So let's just run this whole simulation for all of them just so we can see it. So we're going to do the deep drilling, the additional deep drilling, the pocketing, high-speed pocketing, I should say, and we do the facing, and then we're going to do the profiling, and we're going to do the pocketing, counterbore pocketing, okay, so let's do the slotting. Okay, got the slots in there. Now we're going to do another pocketing. All right, so now let's go do our chamfering. There you go. We've got a nice cut chamfer edge all the way around there. You'll see the tool path, how it extends below the edge. Now, I do want to show you one thing in the parameters. If you don't have a chamfer feature, you just have the edge, then you would use geometry at top, and you look at this little picture here. You see the point that you're selecting is at the top of the part. Okay, obviously this bottom edge is not going to be there because you don't have the chamfer there, so you would select the top edge. Let's cancel out of that. Now what do we have left? Looks like we've got the engraving. This part has a part number on it, as you can see. Now the text has to be curves. In other words, you need to explode this text into individual curve elements and not a text element. Okay, and in most cases you would want a single stroke font, meaning that it's just one line for the text. Okay, by default, if you don't have a single stroke font, Windows font on your computer, just send us an email to support@mecsoft.com and we'll send you the font file for a single stroke font in either Rhino or VisualCAD CAM. Okay, so let's do the engraving. 2-axis engraving, and for the geometry we're going to just Windows select all of that. Okay, right click the tool. We're going to use our V-bit, a tolerance of 1 thou. The location of cut geometry is at the top, and because the curves lie on the top face here. And for a depth, this is up to you. I'm going to put 5 thousandths. See how that looks. Okay, so it's 5 thousandths, 5 thousandths, 5 thousandths. That means it's one cut, one level for all of the text. Okay, and entry and exit, we can do lines and arcs, I guess, and we'll leave it at that. Advanced cut parameters, we'll do arc fitting, sorting, minimum distance. Okay, so here is the engraved text. It's 5 thousandths below the face where the text geometry is located on. Let's go ahead and simulate that. Okay, let's turn that off. So there is our engraved parting line. So, almost done. Let's go ahead and cut the outside perimeter. We'll use a profiling operation. Now, I did mention that this part is being clamped, so we're not going to machine all the way down. Let's go ahead and do a 2-axis. We'll do a profile. For the perimeter, we're going to use the bottom edge. Okay, all the way around. For the tool, we'll go ahead and use our, what do we got? 1/2 inch. And for cut parameters, tolerance of 1 thou, 0 stock. We'll go ahead and for the side to cut, we'll use determined by 3D model. And for the cut levels, the location of our cut geometry is at bottom. Our cut depth, we've been doing this long enough so that we know this is going to be 1.0625. And we will do it at 1/4 inch increments. Okay. Entry and exit, we'll use lines and arcs. And we're going to fit arcs. We don't have any arcs, but we'll go ahead and do it. Corners, sorting. Okay, so let's take a look at that. So here is our profiling. Let's go ahead and set this arc output again. Output control. Turn these off. Click OK. Regenerate that. Okay, so here we got the arc motions, and then we got the linear motions. Let's go and simulate that. There we go. Oh, we didn't want to go all the way down, did we? So we needed to leave room for 0.75. Okay, let's do that again. Okay, we did it at bottom. So in order to do that, we need to change this. If it's set to at bottom, it's always going to go to the bottom. Okay, so we need to change that. For the cut levels, we'll go ahead and use the pick top. We're using pick top because the geometry we select is at the bottom. So we're going to do a pick top, and we're going to tell it the top is right here. And then we're going to go down 3/4 of an inch. Okay, so let's go ahead and simulate that now. Speed that up. Okay, there we go. There's our part. Okay, so that looks like it wraps it up. If you got any questions, I do believe we had one question about can you have the helical entry at each cut level? Yes, there's a checkbox. Let's just look at one of the pocketing operations. There's a checkbox right here for apply entry exit at each cut level, and it'll apply that helical motion at each cut level. Okay. We want to thank you for joining us today, and again, I apologize for the technical difficulties, but we did manage to get through the webinar and get the part programmed. I'm going to put a link to download this part in the description in the YouTube video, so if you want the geometry before and after, you can download it from that link. Okay, y'all have a wonderful day. Take care. We'll see you next month. Bye-bye.